you see this picture here on the board, when you're talking about Newton's universal law of gravitation, you're thinking to yourself, okay, what's going to happen to A, B, and C if I hold these balls in place and then all of a sudden let go, what's going to happen? Is A going to move towards B? Is C going to move towards B? And so on. But what we're going to do is we're only going to focus in on one ball because otherwise it gets too difficult. So if you look at this question, it says determine the net force acting on the middle ball. So ball B here. And just look at the diagram, like 3 different masses and 2 separate distances. So you might have a prediction as to whether B will be more attracted to A or will B be more attracted to C. What's your intuition telling you? Do you think B will be more attracted to A? I mean, C is more massive than A. See, it has more kilograms than A, but it's closer. Which factor is more important, the distance or the masses? Yeah, the distance dominates because of the square. I mean, if this was like the size of planet Earth, then we're talking about a different story here. Like if the mass is way more heavy, way more massive, then it's a different story. But it looks like because all the numbers are pretty similar, it's more dependent upon the distance. So let's check it out. And what I recommend here, guys, is just calculate these things separately and then do the net force. So at the top of the page, we're going to do the force of gravity for A on B. The force of gravity A on B. So what does the force of gravity depend on? You have that universal constant G. That can be found on your data sheet. The 2 masses, what are the 2 masses? 1.5, 3.0. And then you divide it by the distance between them squared, which is 0.5 squared. Okay, so pump that into your calculator, please. Do it with me. If you've been away or whatever, I'll review this one more time. Okay, so it's 6.67 times 10 to the negative 11. So what I do with that, guys, is I type that into my calculator, then I actually hit enter. That way it's stored into my calculator temporarily, but then I can hit this store button down here on the left, STO. So now I'm going to store that to alpha G. Okay, so I hit alpha, then it was the tangent button, but that's alpha G. And that way I can just use G shorthand. Now I go alpha G times the 2 masses, 1.5 times 3, and then I divide by the distance squared, which was 0.5. Now a lot of people will forget the square. Don't forget the square. That's like sometimes you're like, I did everything right, but I'm not getting the answer. You might have forgot the square. Alright, so we got 1.2 times 10 to the negative 9. And which way is that going to make B want to travel? What's the force of A on B? Which way? Towards A. So it looks like everything's on one dimension. So that blue calculation looks like a force pointed to the left. Everything's on a straight line. B is in between A and C. The force of A on B will make B want to go towards A. Now we know Newton's third law. What's this force also going to do to A? A is also going to want to go towards B. So there's an equal and opposite force on A pointing to the right. Okay? We talked a lot about that on Friday. Okay, so let's switch color and let's do the force due to gravity of C on B. Of C on B. Because that's what we're focusing on this question. You know, what's the net force on the middle ball? So A is going to affect B and C is going to affect B. It's the exact same calculation, just with different masses and a different distance. So 3.0 and 2.4 divided by the distance between them squared. Did you guys get 5.3210 to the negative 10? And that one points to the right. I drew the arrow a little bit smaller. This one's 10 to the negative 9, this one's 10 to the negative 10. So the blue one is slightly larger than the red one, which we predicted would be true because it's closer. B is closer to A. And now if we want to determine the net force, which one of those dominates? The blue one dominates, right? So take the blue value. So this would be F net 1.2 times 10 to the negative 9, and then subtract the red value, 5.32 times 10 to the negative 10, and this will give you F net. Did you guys get 6.68? So how many sig digs are we looking at? 2 sig digs? So 6.7 times 10 to the negative 10 newtons. And which force dominated? The left force. So this net force will be pointing to the left. So when you're asked to do a net force calculation for universal gravitation, I would recommend that you just do those calculations separately and then do the net force equation, which is the sum of all forces with just the numerical values. Same ideas as before, like which force is dominating, put that one first. Which force opposes that, put that one second, subtract the two. One-dimensional net force analysis. You guys have seen this lots in this past month. Now this one here will be a two-dimensional force analysis. Oh, sure. Oh, I forgot the acceleration. Go ahead. Yeah, I forgot to answer this one. What is the acceleration? So this is the net force acting on ball B, and that's the net force acting on ball B only for that moment. So the acceleration will be just divided by 3. Yeah, so this is the net force on B, so you can apply that subscript, net force on B. So then if you want the mass of ball B, if you want the acceleration of ball B, you would have to take that force and divide it by 3 kilograms. So 6.7 times 10 to the negative 10 newtons divided by 3 kilograms. .2 times 10 to the minus 10 meters per second square left. So an astronomically small acceleration. It's so small that if these balls were placed on a table, the frictional forces would be way too large. These balls would not want to attract each other due to gravity. You know, they might roll towards each other because of like maybe the surface is unlevel or something. And we talked about that on Friday. These gravitational forces really are only reasonable when you're talking about supermassive things like planets and stars and, you know, space shuttles and things like this. Okay. So we'll do the exact same thing for this question, except it's going to be forces that are at right angles to each other. So it's the exact same question, but like what's the net force on B? So we're going to focus on B. But if you take a look at what's going to happen here, you'll have forces that are at right angles. So this red calculation, that's going to be the force of gravity A on B. Okay, so let's calculate that red one. It's just going to be G 1 times 1 divided by 1 squared. That's just going to be G. Everything's 1. You guys okay with that so far? Everything's 1, so it's just G. It's just G. Now what about the force due to gravity of C on B? This one's going to point to the right. Why is it going to point to the right? Because C attracts B on that line. It's always along the center of the masses. Okay, so G, the two masses, so 1.0 and 2.0, divided by the distance between them squared. Okay, this one will actually calculate to a number different than G. Times 1 times 2 divided by 1.3 squared. I got 7.89 times 10 to the negative 11 newtons. Okay, so one force points down, the other force points right. So if you have two forces that are perpendicular to each other, the best strategy is to draw a right angle triangle. Remember, you have to draw them tail to tip. So if one force points down and the other force points right, which one's larger? The blue is slightly larger. Okay, this is the force of A on B. This is the force of C on B. And then the hypotenuse, of course, is the resultant. So that's what we're doing here. One force points down, the other force points right. So when you put them together, that force is going to be somewhere right of down, or down of right. You take the two magnitudes, you do the Pythagorean theorem, you take the two magnitudes, and you do an inverse tangent. All right, so 6.67 times 10 to the negative 11 squared plus the 7.89 times 10 to the negative 11 squared. That's the resultant magnitude. Zoom in for you guys. Need a calculator? No, I just, those are the different ones. Okay, I got 1.0 times 10 to the negative 10 newtons. You guys get that as well? Did you get that? 1.2. You got 1.0? Okay, and then how are we going to find this angle here? So I've drawn an angle with the y-axis. You can also draw your angle with the x-axis. So for me, I have inverse tan. It'll be FCB over FAB. Opposite over adjacent. This will give me theta. So inverse tan FCB is the larger one, 7.89. Divided by FAB. I got about 50 degrees. And that would be to the right of down. Or you could say, you know, east of south. The other alternative, of course, would be 40 degrees down of right. Both of those are fine. Either of those are fine. They're both correct. As long as you identify it. Like here, you got to know your geometry for physics 20. You got to know, like, if I drew the tail to tip diagram, this angle's made with the y-axis, whereas if I drew it the other way, I drew the right first and then the down, and then drew the resultant. Then this one will be the 40 degrees, right? Here's the 50, here's the 40. Depends on how you draw it. Okay, so a net force in one dimension using Newton's law of universal gravitation, and a net force in two dimensions, but it's right angled, so it's quite nice, also using Newton's law of universal gravitation. This one here is a challenge. I'm gonna let you guys have this one. I'm not gonna test this. You do need to know how to solve a quadratic equation in order to solve this one. So this is completely a challenge bonus question if you're interested. I take it up in Physics 30, but I'll leave this one as a challenge. So this homework here, I've already assigned about half of this. So I'll show you the new stuff that you need to do, and then I'll give you a quiz at the end of the block. Okay, so in the homework here, page 248, most of this should already have been accomplished. You had a couple days for this. So basically it starts on 12. Like, I'll even do 12 for you because it's so easy. Look at 12. 12 is exactly what we started the class with, except you don't have to do the original question. So what's the net force acting on ball 2 here? Well, it's the force of 3 on 2. Take away the force of 1 on 2. Because this force is larger than that force. So you have 9.0 times 10 to the negative 9. Take away 5.0 times 10 to the negative 9. And that ends up as 4.0 times 10 to the negative. It's just a typo. It's just a typo. So it's the exact same question we did, but the original calculations you don't have to do. They gave it to them for free. So did you guys see how this force to the right is going to dominate? Just look at the size of this arrow. Look at the size of this arrow. This much has to be canceled off that one. And this is the net force right here. That net force is the leftover force that points to the right. So the F net onto will be this many newtons to the right, 4.0 times 10 to the negative 9. Okay, so let's finish off the rest as homework. I'll leave it up here. But now for this one, exact same question, except you have to do those preliminary calculations. You have to use the FG formula. And then look at this. It wants you to do it on sphere 2 and then on sphere 3. So be mindful of which sphere you're talking about. And then here is question 14. This is when you have to do the right angle triangle. Okay? So 12, 13, and 14 in the next 15 minutes or so. Well, 13 and 14 because I just did 12 for you. I did 12. So 13 and 14 in the next 15, 20 minutes. I'll be walking around helping, and then I will give you the quiz.